Yeah. Hello, everybody. I believe... Are we? Yeah, we're there. Okay. So, I'm slightly thrown that my bubble's gone, but I'm pretty sure we are still recording.
We are.
Amazing.
That's how it works.
Okay, thanks, Miss Beresford. Now, hello, everybody. The reason that this video will be even more amateurish than our usual offerings is this is the first time we have used an app called Loom. L-O-O-M, by the way. And as a result, we're using this as a test for our learning on Wednesday, which at the moment is tomorrow, but tomorrow will be today. It's profound. Now, we will be learning in the junior classroom, we'll be learning about angles. And as a result, I'm going to go through this PowerPoint as a supplement to help you understand what you need to do to be able to answer the questions you took home or your parents took home on Tuesday evening. Okay, so please make sure you can see the screen. I'm going to make it go full screen. There are 12 slides and I'm going to go through them. There's no need to note take or anything like that because you can just rewind it, of course. Okay, so we've got our good old angles here. Angles is one of my favourite things to teach because it involves lots of straight lines. And I think certain boys and men are very keen on straight lines. Firstly, we've got the good old right angle. A right angle is marked, as you can see, by a kind of square, and it is when two lines are perpendicular. It's the opposite of parallel. You can do it, of course. If we were in the classroom, I'd make you all do it with your arms, as you know, which you all find hilarious to do. That is a right angle, and it is called 90 degrees. Okay, this will all make sense as you proceed with the work. But for now, it's important to recognise a right angle, a corner, as 90 degrees. The key point, as you can see here, it says a half turn, 180 degrees. Two right angles is also a straight line. Think of a ruler. Think of the ruler we generously gave you yesterday. That straight line is 180 degrees. You then have a circle or a full turn, which is two straight lines, 360 degrees. Whenever you see angles, it's very likely you will need the numbers 90, the numbers 180, and the number 360. Okay, line, as you can see. If you remember from the previous slide, straight line is 180 degrees. The angle is 180 degrees. A key point for later in the week is to understand that in a triangle, the three interior inside angles also add up to 180. It is a key number in geometry. Euclid's a big fan of it. And here we are at the point of the questions which you need to answer. Okay, you will have a lot of questions in geometry where you are solving what we call missing angle problems. What you've got here is a straight line with a second line making a kind of, what shape would you say that is? Okay, it's kind of a bit of a triangle. If it were, it's like a
mouse.
God, it's a mouse. Would you say mouse, Mrs. Wanham?
A crocodile.
Crocodile. So I go hedgehog's nose.
Very similar to a mouse,
Yeah, okay,
really,
we'll go with
isn't
that,
it?
yeah, okay. But you can see...
Little blobs, it's like very nose, and then it's like its muzzle.
Okay, so as you can see here, we are working out the missing angle, which has been marked with a letter A. Again, quite common to mark it that way, but we have been given a key bit of advice. The larger of the two angles, the obtuse, remember that word angle because it's over 90 degrees, is 141 degrees. Happily, we know that a straight line, the angles have to total 180, and there's only one more angle to calculate. Miss Beresford, what could we do, therefore, to work out the size of angle A?
I wonder, could we maybe do 180 take away 141?
Oh, she's good at this. We could. If you think the total of all of the angles has to equal 180. We've got 141, so we need to get to 180. So if we arachite them, we'll just say the answer is 39 because 141 and 39 is 180. However, that method is prone to mistake. You can rush, you can make an easy mistake. As Miss Beresford said, if you were to do 180, subtract 141, you would get 39, and that would be the answer. Okay, ignore the bit at the top on the whiteboard. You don't need to do that, but here are some examples. Firstly, the one on the left in a nice kind of purpley font. Will you say purple, Mrs. Wallen?
Yes.
Yeah, good. Right, you're right there. Great. You can see that the answer is written in red of 75. The reason that's the correct answer is the two numbers have to total 180. 105 and 75 makes 180. Now, the one on the right is just the same. It looks hard, and often with geometry, it looks impossible, and it makes children have a bit of a meltdown because they don't understand it, when really you do understand it, children. You know a straight line is 180 degrees. You know all the angles must equal 180 degrees. So you've got a 55, you had a 38, you would add those two numbers together to get 93. Okay. Whatever number is left to make 180 would be the answer. As Miss Beresford said, you could subtract the numbers from 180, or you have to work out what the number is which you add to your total to make 180. Oh, a full turn. How big's a full turn on a circle, Mrs. Wallen?
360 degrees.
Boom. Okay, we're doing well. Okay, two straight lines. If you look at the red line and imagine it going all the way through the circle, that would be 180. It's two of those, which is 360. But you know what? It's just the same maths. Here we've got a circle. As you can see, it's a slightly dented circle because the bit by 103 is kind of in, but you are making a circle that way. So you know all of the angles, however many there are, whether there are 10, whether there are 2, whether there are 5, must total 360. We've got two angles already, 103 and 158. They would total 261. Miss Beresford, what would we do, therefore, to work out angle B?
Well, we take 360 and we take away 261 from it to get the gap.
It's good, isn't it? Yep. And the answer would be 99. We're finding the difference. We're using all sorts of mathematical language. Well done. Posher ways of doing it. And again, these are kind of algebraic ways for year 6 children preparing for secondary. You can see you've got missing angle A, missing angle B. If you were to write that as an equation, it would be A add B equals 180. On a circle, it doesn't matter what letters you put in there, but you are adding them together and they must equal 360. Now, these are, at this point, sorry, children, if you are in year 3, year 4, year 5, and you're not feeling 100% confident, have a go at a few. Maybe watch it again and then have a go at a few of the questions in your pack. If you're feeling confident, have a look at this. Because again, it looks really complicated. Oh, we've got, like a little bow tie, would you say?
Yes.
We've got 2 colours. We've got A, B, C, D. We've got no numbers. Oh my goodness. It's so easy, children. You can see it's a circle again. So the total of the 4 will be 360. When 2 lines intersect, that means cross over, the opposite angles will be the same. So angle A and angle C will be the same number. Angle D and angle B will be the same number. And it's easy because if you look at it, they look the same. So have a look at that. We've got intersecting lines here. We've got G, which is 48. Miss Beresford, which other angle will also be 48?
Could be the one that's opposite it, so F.
Good. Well done, Miss Beresford. So F would also be 48. Now, what's really good here is if we're in year 6, this is very advanced even for year 6, but if we're getting ready for year 7, year 8, year 9, we can actually work out the angles D and E because we know G is 48 and we know F is 48. And because we really like maths, we know 48 add 48 is 96. Yeah. No, I was. So we know that we've got half of the angles which make 96. Now, we could subtract that from 360. Going to enjoy this. And we'd get 264, wouldn't we? Now, if you half that, you'd get angles D and E. That would be one way to do it.
I can see another way.
Go for it, Mrs. Warren. Go. This is why it's so fun. Yeah.
So
you were surprised I was taking that. Sorry.
Oh.
No, you carry on.
I would have to find angle D, which would obviously be the same as angle E.
Are you seeing straight lines?
I would see straight lines. So I see a straight line going along, and G is 48 degrees. So I know that G and D together must equal 180 degrees.
She's good, isn't she?
So I
really
do 180 take 48 degrees to take away 48 degrees to find D. So that is 132 degrees. So then, because I've worked out D is 132, am I supposed to be saying all this?
I'd carry on.
D is 132, so then E must be 132 degrees as well. That's very good, okay.
Wow. There you have it, children. That's home learning completed for 6 weeks. Brilliant. Okay. It is that easy. Okay. You can do it, children. A little bit of practice, 2-3 days, and this will be easy peasy, lemon squeezy. Okay. What Miss Iswallen was saying there very clearly is if you look at the blue line here, you'll see it has, it looks like a fried egg. The blue line with the bit there, or a hill. Flying saucer, okay. That flying saucer demonstrates to you that it is a straight line, and you know that the angles on a straight line add up to 180. What Mrs. Wallen was doing then was bringing together the knowledge she had about different types of angles to help her solve the problem, and you can do it too, okay? Now, triangles. If we whiz, this is going to make you all feel sick, so I'm going to whiz right back to the first slide, the second one, sorry. Here was that early knowledge. 90 degrees is a right angle, 2 perpendicular lines making a corner. 180 degrees was a half turn, 360 degrees was a circle or a full turn. In a triangle, it says, the 3 interior, the inside angles, also add up to 180. So, if we go back to this, we can actually answer questions such as this. Okay, this is a scaling triangle because all the angles are a bit different. We know all the angles inside a triangle add up to 180. We've got 2 of them, 56 and 31, which if we add together, we get 87. So now, what do you think we have to do, children? We have to subtract 87 from 180, or to get the same answer, we have to work out what number we add to 87 to get to 180. If it were me, I'd use column subtraction, would you, Mrs. Wallen? Yeah, and you'd get an answer of 93 for angle A. These ones are just so fun. It's like heaven, isn't it, Miss Beresford?
Yeah.
Okay. Now, in number 1, you'll think, oh, it's a right angle triangle, but hang on a minute, there's only 1 angle. I need 2 angles to work out the third. Yes, but what is a right angle? What is it?
It's 90 degrees.
Oh, it's 90 degrees. So that little right angle, we could write 90 by, if I could afford Shobi for school and actually write on the screen, I'd do that. But on Loom, you can't do that. But if we know that's 90, we know the other angle is 42, which equals 132. Angle A will be 48. Yeah, it is that easy. An equilateral triangle's almost got the word equal, or it's got the word equal spelt very badly in it. It just means all 3 angles are the same, 60, 60, and 60. Funnily enough, if you add those together, you get 180. Now, an isosceles triangle has 2 angles which are the same. Key point to remember for year 6s. An isosceles triangle has 2 parts which are the same. Do you know this one, Mrs. Wallen?
Yeah, I do.
The top angle's 20, which leaves 160 degrees left between two angles, which are the same. So what are we going to do?
So we have to split 160 between 2 or divide it between 2. So 160 divided by 2 is 80. So each of those angles, I can't see what they are, C and D, is 80 degrees.
Well done. Thank you, Mrs. Wallen. Now, a scaling triangle, I always call a wonky triangle, Miss Beresford. It's wonky. All the angles are different. So with that, you do need two of the angles. You've got 72 and 68, which is 140. I hope. Yes, it is. So E's really easy because you've got to go 100. So from 140 to 180 is 40 more. So E's 40. Okay. Now that gives you a brief introduction to angles. You know you can email me if there's anything you don't understand, but before doing that, watch the video again. There is nothing in here which is too hard for anybody in my maths group. You are very, very good at maths and you can do this. Okay? Can't wait to see some of your work, which you can email to homelearning@muggington.derbyshire.sch.uk. You know you can ask if you need any help. Okay? Please try your best, and I can't wait to see your answers.
Bye.